Hi everyone, I'm Harry, and today I'll be talking about how Airbnb uses machine learning to value homes. So today we stand in a very fast-paced, data-driven world. People are traveling constantly and they wish to have not just lodging, but convenience and at a great price as well. They want the entire package. So Airbnb is a service that tries to fill this specific expectation, and in order to do so, they need a lot of data. So the pricing and value of listings on Airbnb have to remain competitive and have to be lucrative enough for both the company and the renters. Here, the machine learning modeling is on a statistic called LTV, lifetime value, which helps the company estimate the revenue specific listings can bring. I'll talk a little bit about this later. So this case study will explore the implementation of machine learning in classification of data and the four-step modeling process of building efficient models that help estimate LTV. And furthermore, the immediate benefits and potential extending LTV models into social policy will also be discussed. Here's the data summary. Initially, I'd like to talk about the data directly mentioned in the article. So location data is very important, like country, market, neighborhood, geographical features. This kind of data directly relates to the property value, and different areas have different prices, and proximity to landmarks, public transit, etc., can also significantly alter the desirability for a renter. Next up, price data, like nightly fees, cleaning fees, price relative to similar listings. These pricing and fees directly affect the base value and potential of the platform, as well as a guest's decision to book. Next, availability data, which is like the total nights available and nights that have been manually blocked by the person. So availability also directly affects revenue potential. The act of manually blocking nights may also suggest that a person is doing strategic withholding, perhaps trying to create scarcity and stuff like that, which can also alter revenue. So bookability is also really important. So which means like this successful bookings in the past X day of a specific listing. So high bookability suggests that a listing is very well performing and it makes it more attractive for future guests. And this usually raises its predicted value. Quality data like review scores, number of reviews, amenities are also important because they're seen by most viewers that are looking to book the place, and it affects the listing's reputation. And the amount of amenities and reputation of a listing is also positively correlated with its perceived value and desirability. So other potentially important data commonly used in valuation models of properties are starting with its characteristics. So property type, how many bedrooms it has, how many bathrooms it has, how many square footage it is, what year it was built in. So these physical attributes also directly impact its value. Because the size and number of rooms may allow for more guests or less guests, and all of this affects revenue potential. So the background of the host, such as their experience, how many properties they have, their response rate, if they're verified, also very important, because for quick rentals like Airbnb, an experienced and highly responsive host who can help solve issues quickly usually leads to a more positive guest experience. So seasonality, like if it's what season it is and if there's holidays, is also very important because seasonality has great impact on the demands of like quickly renting things like on Airbnb. And looking at the patterns over the years is required to accurately forecast occupancy rates at different times over the year. The competitive landscape is also, we cannot ignore this because we cannot look at a listing in its vacuum. We need the context of how it competes with other listings in its area. So this allows us to look at where the listing can potentially differentiate itself and also provides a range of competitive prices that the listing can be set at. Historical data is also really important. So the price history, booking history, occupancy history, trends and patterns that are crucial for predictive modeling. So this helps us understand the cyclical trends and market dynamics. And of course, user interaction, such as search query, what people are searching, what people are actually clicking on. This reflects online interest in a listing and can be used to model how appealing the listing is to online guests, which will influence its perceived value as well. Next, I'll go through summary of the methods and model we'll be using. So machine learning workflow for LTV modeling has like a greater framework. So firstly, LTV, what is it? Customer lifetime value. So it's basically a statistical metric that estimates the total value that a customer can bring during an entire duration of a business. So for Airbnb, LTV will predict how much future revenue a specific listing will bring over a set amount of time. So successfully estimating an LTV for listings can help Airbnb allocate their marketing budgets more efficiently, as they would know which listings to weigh more. It can also help them with establishing competitive pricing and prioritizing resources and support to listings that they think have higher value. And here's the 4-step process. You can quickly take a look at the small diagrams that have been included. So yeah, let's start on feature engineering. So during the first step of feature engineering, data scientists create, select, and transform variables that they will put into the ML model. They define the relevant features that are correlated with LTV, and they ensure that they're in the correct format for the model training. And an important tool used by Airbnb is Zipline. Zipline is an internal feature repository for Airbnb that allows quick and scalable creation of variables. It also allows data scientists to easily share the variables with each other and support features at different levels. So at a host, guest, listing, and market variable level, people would love to it would be really convenient for them to see the variables at these different levels. So with Zipline, they can define a relevant feature that is correlated to the LTV using already existing features to create new ones, to create new features. Zipline also helps with intelligent key joins, which means joining different tables with foreign keys, and also helps the backfill training data, which means creating a point-in-time consistent sample of the feature data. Next up is prototyping and training. So during this step, scientists build initial models, and then they use historical data to learn patterns that help predict the target variable. Here they can also experiment with different types of model architectures and data processing to find the most promising ones, and this will help us develop a model pipeline, which is where they will do all the data transformations and the initial training of the model. So the tools used here, a very important one is scikit-learn, which is a machine learning library in Python that provides tools for data analysts, analysis, and data mining. So the tools here help with classification, regression, clustering, and more, and to help process and transform data. So with this, the pipelines are created. Basically, data imputation is another thing that they do. So data scientists can check if there's missing data and if the missing data is random. If it's not random, they have to find the cause why it's not random and have to fix that. And if it is random, they can impute the missing values, potentially with the values that they already have. It's kind of like Bootstrap that we talked about. Encoding categorical variables is also something they do with scikit. So raw categories in a model are not always usable, as models may not always be able to fit strings. And with a lower number of categories, they can use one-hot encoding. So basically, they can create binary columns for each category. And when there's really high cardinality, they can use ordinal encoding, which is encoding by the frequency count of each category. And pipelines is also something that's really important. So basically, this abstracts the details away from data transformations, which allows efficient and rapid iteration when prototyping. So pipelines themselves are constructs that allow scientists to specify steps in data transformations and model training in a pretty high-level blueprint. On the left is a snippet from Airbnb's LTV pipeline, and on the right is a sample abstracted ML pipeline. You can take a look if you're curious. And yeah, next up is the third step, which is model selection and validation. So during this step, we evaluate, compare, and contrast different machine learning models to find the ones that perform the best based on specific criteria. And some criteria may include accuracy, interpretability, computational efficiency, etc. All stuff we talked about throughout the course. So first, we have to talk about something called the bias variance trade-off, which is a trade-off between the model complexity and interpretability. So for instance, a linear model is super interpretable, as we talked about before, but it is not very generalizable in many situations. So you can't really use a linear model for that many things. A tree, on the other hand, a tree-based model may be very flexible, but really hard to interpret with all of the different classifications and all of the different things it can represent. So for Airbnb's purpose of getting specific predictions of listing values, it was more important to favor flexibility over simplicity and interpretability. So we want a model that can best generalize to new varied data and still produce low out-of-sample errors, basically. So an important tool used here is AutoML tools such as AutoSKLearn, Teapot, H2O, and AutoML. So these are various different frameworks that help automate model selection, hyperparameter tuning, which means to tweak parameters that affect the structure, function, and performance of the model, which can potentially determine the accuracy and the results, and the speed of convergence, so how fast the model actually converges to like an answer that it likes. And it also helps perform performance benchmarking and accelerates the process of finding the highest performing model. Sorry. And XGBoost is another very important tool. It stands for extreme gradient boosted trees. So this is a tree-based open source software library. It is very fast and flexible, and it does gradient boosting, which means combining the predictions of weak learners into stronger learners. And it's a framework that does that. We didn't really talk about this too much in this class, but I'm sure we can all explore this in the future. Another important tool is cross-validation, or K-fold. This is something we did talk about in class. Although they didn't really mention this directly in the article, I personally predict that cross-validation, because it usually plays a really large role in ensuring generalizable and robust models, they probably would have used this on the various types of data that we mentioned before in order to identify the best fitting model configurations and prevent overfitting. And this is the most promising LTV models would be selected before deployment. I think this was probably done through the different tools that I mentioned above as well. So yeah. Lastly, step 4 is productionization. So during this step, we finally deploy a machine learning model to its production environment, where it will make real-time predictions of LTV values. However, we'll still need to pay attention to the model itself and do retraining and scoring of the model to be sure that it can reliably and efficiently work in a real-world setting. So ML Automator, so the tool we use here is called ML Automator, and it's a framework that automates the translation of Jupyter notebooks into Airflow ML pipelines. Basically, it automates data serialization, scheduled periodic retraining, distributive scoring, and similar tasks. This way, data scientists can transition from prototyping to actual production without too much extensive help from data engineers. So this will save Airbnb some time and like a lot of money in hiring data engineers. And another tool used here is Airflow, which is an open source platform that programmatically authors, monitors, and schedules workflows, which it also helps create DAGs, which means directed acyclic graphs, which means graphs with nodes that only point in one direction. And this can be used to represent processes and pipelines at a really high level. This is used together with the ML Automator in order to manage the production of the pipelines. And it's a very programmatic way for data scientists themselves to approach the production process without the guidance of data engineers. And yeah, that was basically the process, and I'll now talk a little bit about the results and limitations. So immediate benefits, firstly, robust pricing models. The machine learning models consider a lot more factors and data points than singular regressions, and thus it might help provide a more all-encompassing holistic predictions for pricings. This will help Airbnb set competitive prices that may maximize their revenue economically, and this can be shown through an increase in average booking rates, higher occupancy rates, and even improved revenue per listing. Another immediate benefit is a more efficient allocation of resources. So if we assume that LTV is a good and unbiased metric that measures how valuable a listing is, knowing the LTV of each listing can help Airbnb allocate their marketing and development budget more effectively. They can put emphasis on listings or areas with higher average LTVs. And yeah, this can be shown through a better return on investment of the budget for each listing or area. Next up, another immediate benefit is a more efficient and insightful operation process. So the entire ML LTV modeling process is super streamlined, and from engineering variables to final production and deployment of the model, it's all very streamlined. And this is a lot faster than having data scientists run and rerun regressions every time a variable changes. And this can be shown through lower model development time and potentially lower operational costs. And furthermore, valuable feedback can also be given at any stage of this multi-stage process. For instance, the data scientists will get more used to what type of variable works in what kind of model in the first stage, or they can discover a sweet spot in between the bias variance trade-off in the third stage. There can be continuous improvement in the process, which may lead to even better models in the future. Despite these immediate benefits, there are also some limitations and shortcomings that I thought about when doing this project. So firstly is the interpretability of the model, as we mentioned earlier. Favoring flexibility and using XGBoost causes many parts of the model to lack interpretability, And this makes the model hard to debug and explain to the stakeholders in this entire process. So one avenue of improvement may be to use SHAP, which is Shapley Additive Explanations. This is a game theory-based method that assigns importance values to each feature of the model based on their contribution to the output. And the output is broken down into the sum of each feature's impact, making it easier to explain. Another limitation is the quality and the completeness of the data. So the accuracy of the LTV prediction really heavily relies on the quality and completeness of the data being used. Things like false ratings, false reporting, bad predictions of bookability, etc. This may all lead to poor model performance and unreliable predictions. Furthermore, the real estate rental market is super dynamic and changes all the time, so the model cannot absolutely it cannot be static. And an avenue of improvement here is we require frequent checks and updates of the data, as well as very robust data validation, cleaning, and imputation. And we can do this throughout the process that we mentioned above. The last thing is bias and fairness. Biases can occur if training data of certain neighborhoods, demographic, or other groups have historical biases, such as like maybe a neighborhood had always been undervalued or underserved. And there could also be sampling bias, where listings used are not representative of the entire population. There can also be measurement bias and biased guest behavior, and this all could result in inaccurate LTV measurements. So an avenue of improvement in this case is to use fairness-aware algorithms like reweighting or resampling, and in order to adjust for biases and having fairness constraints. So we could also enact fairness audits, which is we can evaluate whether the model predicts systemically lower values for certain areas, and we can gather and ensure diverse and representable training data in this way. Yeah, and lastly, talking about inference application of this entire project of LTV modeling. So inference application, I wish to focus a little bit more on economic and social policy, because modeling LTV can be used to ensure equity just as much as it could be used to maximize revenue. So the first thing is machine learning in urban planning. So instead of predicting the lifetime values of specific listings, I think the LTV model can be altered, perhaps with different data and algorithms that the government has, in order to forecast the impact of large development projects and on nearby property values. So how much a certain developmental project will affect the nearby listings and their prices. So this can help urban planners make zoning decisions and ensure a balanced development in a city. This can also prevent errors such as market distortions that are caused by new developmental projects. Another thing that we can use in inference is LTV modeling in affordable housing. So LTV modeling can quickly help the government discover properties that may be undervalued versus properties that may be overvalued and other things like this. So with these predictions in mind, policymakers can make decisions regarding subsidies and investments into affordable housing initiatives with the properties that can fit their plan the best. This leads to a more efficient use of public funds and may allow for more low-income families to find suitable and affordable homes. So LTV modeling in property taxation is another good inference. So use LTV prediction to value other residential properties. This can help local governments quickly and accurately assess the property's value. However, I'd like to say that the models used by the government should value interpretability because they really need this to keep the transparency with homeowners on what elements determine the pricing of their home. So together, this can provide fair property tax assessments, and as a result, there may be less people disputing and more people complying, and a greater public satisfaction with the government in that sense. So yeah. In conclusion, the integration of machine learning into Airbnb's business has certainly presented many benefits. Using predicted LTV of listings, the company is now able to optimize their pricing strategies and allocate their budgets more effectively. These immediate benefits also shed light into the potential of similar machine learning models used in social policy. And using insights from Airbnb's successes, the government can certainly develop and train their own models on data regarding the city. And this can potentially lead to more equitable urban development, a more efficient use of public funds, more fair property assessments. And as machine learning continues to evolve, we will no doubt start to see similar innovations in all different fields. Here are some citations, and thank you.